Basic electrical learning.
Hello guys, welcome to my channel Basic Electrical Learning, and today we are going to learn about basic law of electrical system, and that is Ohm's law. In this lesson we will discuss about Ohm's law. We will find how to find the voltage, how to find the current, how to find the resistance, and we also discuss about Ohm's law triangle, that how can we use this triangle to remember the equation, and at the end we will do some numerical problems. Actually, Ohm's law show the relationship between voltage, current and resistance. These are three electrical terms, and this relation is shows through the equation, that is V is equal to IR. But there is the confusion in some people, and that is voltage is directly proportional to the current, or the current is directly proportional to the voltage. So let's see which equation is right. Ohm's law states, for a fixed metal conductor with temperature and other conditions remain constant, the current through it is proportional to the potential difference between the ends. So you can see here, when the voltage is 3 volt, the current is 0.3 ampere, and when the voltage is 6 volt, the current is 0.16 ampere. So here 3 volt 0.3 ampere, and with the fixed resistor 6 volt 0.6 ampere. So you can see that double the current will glow the bulb more brightly. So as per Ohm's law, current is directly proportional to the voltage, and where we remove the sign of proportionality, we will find that current I is equal to G, that is conductance, and V. So conductance also affect to the current. And what is conductance? Conductance G is the opposite of resistance and tells us how easy it is for the current to flow through something. Conductance is measured in Siemens, and another term for the Siemens is mho, and as the reciprocal of resistance. It is the word ohm spelled backward. So the conductance can be calculated using the equation. For example, G is equal to 1 over R, or G is equal to I over V. So in electrical system we seldom use the conductance. We use another term, that is the reciprocal of conductance, that is resistance. So we will use the resistance. So G will be replaced by resistance, that is 1 over R. So our equation will become I is equal to 1 over R V, or IR is equal to V, or as we normally say for the Ohm's law, that is V is equal to IR. As a quick refresher, the triangle is a visual representation for the mathematical relationship between voltage. Sometimes voltage also shows with E, that is EMF, and resistance R, and the current I. So this is a triangle which is used to remember the Ohm's law formula, and very easy to use this triangle. Let's see. So to find out the voltage, what you have to do, you have to cover the V with the hand, and the remaining equation is I multiplied by R. So your equation will be V is equal to IR. So that is a quick remember tool for the Ohm's law. Let's see another situation to find out the current. Now cover the current with the hand or with something others, and remaining equation will be V divided by R. So it will become I is equal to V divided by R. And for the resistance, to find out the resistance R, so once again we will cover the R here, and the remaining equation will be V divided by I, and our equation will become resistance is equal to V divided by I. So there are some examples. Let's see. There is a situation for us. How to find out the voltage with the help of Ohm's law? Let's see. So in this circuit diagram, you can see there is a voltage source, there is a resistance, and there is a multimeter which will show the ampere. So what will be the voltage? So what will be the source of voltage if we have a 4 ohm resistor and current flowing through that resistor is 2 ampere? So once again we will use Ohm's law, that is V is equal to IR. Here we will use, by covering the V, the equation will become V is equal to IR, and by putting the value I for 2 ampere, R for 4 ohm, and our equation will become V is equal to 8 volt. So it is very simple to use Ohm law for the voltage. So our voltage source will be of a 8 volt. Now in this situation, when the voltage is double, the current also double, as we know, that is Ohm's law. If the voltage is double, that is 8 volt and 8 volt. So 8 plus 8, it will become 16 volt. So now if you have a 16 volt, what will be the effect on the current? Definitely current will double. So doubling the voltage, double the current. So the current is directly proportional to the voltage. Here you can see when the voltage is 8, the current is 2 ampere, and when the voltage is 16, the current will become 4 ampere. Remember that the resistance is remains same. So as per Ohm law, in doubling the voltage will double the current. Double the voltage and double the current with the constant resistance. Now how to find out the current? Here you can see that 9 volt battery is connected with a 6 ohm resistance load, that is a bulb, and we have to find out the current. So there is no current is showing on the multimeter, so we have to first calculate with the help of Ohm's law equation. Again in this equation we will cover the I. The equation will become V divided by R. So I will become V divided by R, and V is the 9 volt and R is the 6 ohm, and 9 divided by 6, it will become 1.5 ampere. So the current in this circuit will be 1.5 ampere. When the resistance is doubled, the current is become half. So you can see here there are the 2 resistors, 2 loads are connected in series. Now the resistance will become 6 plus 6, 12 ohm, and the current become half. So by increasing the resistance, the current will decrease as per Ohm law. Double the resistance, half the current. More the resistance, less the current. As we know, by further increasing the resistance, the current will become lesser and more lesser. So you can see 9 volt and 6 ohm, the current is 1.5. When the battery is 9 volt but the resistance is 12 ohm, the current will become 0.75 ampere, and by further increasing the resistance, the current will become 0.5 ampere. So the bulb 1 is more brighter, this bulb is little bit bright, but these bulb are very dim, because the current for each bulb is become 0.5 ampere. And to find out the resistance, so here is 9 volt battery and the current is 0.5 ampere, and we have to find out the resistance. Again we will use the same formula, that is by covering the R with the help of this triangle. the remaining equation will become V divided by I. So R is equal to V divided by I. So 9 volt divided by 0.5 ampere, and the resistance will become R is equal to 18 ohm. So in this equation the resistance will be 18 ohm for this circuit. As we know, as per Ohm law, the current is inversely proportional to the resistance. Higher the resistance, lower the current, and lower the resistance, higher the current. So when the resistance is doubled, the current will become less, that is 1.5 ampere. When the resistance become 3 times, the current will further decrease and it will become 1 ampere for this circuit, and the flow of charge will decrease, rate of flow of charge will slow down. So here in the graph you can see, by increasing the resistance in ohm, there is decrease in the current. And remember that when the voltage is remain constant. So there is a problem, the numerical here we are going to solve that. The problem 1 is, there is a bulb operating with the current of 2.5 ampere as shown in multimeter, and the resistance of the bulb is 4.8 ohm as shown here. What is the operating voltage of this bulb? Now we have to find out the voltage of that battery or this source. Let's see. Again we will use Ohm law. And here actually we are going to find out the voltage, so we will cover the voltage. The remaining equation will become IR. So V is equal to IR, and here as we know I is 2.5 ampere and R is 4.8 ohm. So by multiplying these two values, the voltage will become 12 volts. So in this situation, the voltage of the source is 12 volt. Now come to the next problem. In this problem you can see here there is a socket of 220 volt socket, and the current is flowing is 6.25 ampere. So an electrical heater is connected with the 240 volt power supply and draws a 6.25 ampere current. What will be the resistance of this heater? Now with the help of Ohm law we will find out the resistance of that heater. So again we will use Ohm's triangle. By covering the R, the remaining equation will become V divided by I. So R is equal to V divided by I. By putting the value, V is 240 divided by 6.25 ampere current. By solving this equation with the help of calculator, we will find out the resistance of that heater is 38.4 ohms. Now problem number 3. In this problem we will find the current. So an electrical component lamp or light with 8 ohm resistance is connected across 20 volt battery. Now we have the voltage and we have a resistance. So how much current passing through this lamp? So the current is passing as we know, but what is the amount of current? We will use the Ohm law again by using the Ohm triangle. By covering the I, the remaining equation is V divided by R, that is I is equal to V divided by R. By putting the value here, that is 20 volt divided by 8 ohm, then the current will be 2.5 ampere. So the current for this lamp is 2.5 ampere we have found with the help of Ohm's law. So for a quick revision, that is, as we know, as per Ohm law, I is directly proportional to the voltage and I is equal to conductance multiplied by voltage, that is conductance is the ability of a conductor to conduct the current, and as we know the conductance is the reciprocal of resistance, so we will replace the conductance with the help by using the 1 over R and our equation will become V is equal to IR. So that is Ohm's triangle. In this Ohm triangle we can find three different value. By covering one value, for example here, by covering the V, the equation will become IR. If you want to find out the current, by covering the I, the equation will become V divided by R. And to find out the resistance, we will cover the resistance and the remaining equation will become V divided by I. So gentlemen, that was all about simple Ohm's law equation. Thank you very much for watching this video. Thank you.